Okay, we're going to go over some extra trigonometric substitution examples. I promised I'd get back to you guys. So we're focusing on the case where you have integrals involving the square root of x squared plus a squared, where x will be a tangent theta, and then our radical will be a secant theta. Okay. Tangent, secant. So for this question, you may notice that we don't even have a radical, but we can still do trig substitution here. Let me show you what I mean by that. A squared will be 9. So if a squared is 9, we've seen over and over again, a has to be positive. So a is going to be plus or minus the square root of 9, or plus or minus 3, but we said a has to be positive. So here's our a value. So remember, even though we don't have a radical, we're going to let x equal 3 tangent theta now. All right, so then you might say, well, what would x squared plus 9 be with this substitution? Well, you'll get 3 tangent theta squared plus 9, which will give us 9 tangent squared theta plus 9. Factor out the 9, and you'll get tangent squared theta plus 1, or simply 9 secant squared theta. So this is going to go in your denominator position down here. Okay, so x squared now plus 9 is 9 secant squared theta down here. The dx part, since x is 3 tangent theta, the derivative of tangent is secant squared theta. So we get this dx for our trig substitution. Okay, so let's put everything together here. This will be the integral now of 1 over x squared plus 9. That's going to be 9 secant squared theta squared down there, and I guess we do need some more, I should say, space. So there's my denominator raised to the second power, because that's what you have here. X squared plus 9 raised to that second power. Now the dx part goes here, which will be 3 secant squared theta d theta. So, all right, let's double check. Make sure everything is what it should be. Dx, okay. So we're going to do some algebra here. And notice in the denominator, 9 squared is 81, and then secant squared is secant to the 4th. So that we'll get 3 here, and I believe this is 27 now. And the secant squared will cancel, and this is power 2. So you have the integral of 1 over 27 secant squared theta d theta. Okay, it looks like it's okay. Now, pull out the factor of 1 over 27. You get 1 over secant squared theta d theta, which will give you 1 over 27. You're going to integrate cosine squared theta d theta. So we're going to have to use that half angle identity, 1/2, 1 plus cosine 2 theta, or the double angle. It's actually called power reducing as well. Anyway. So let's pull out the factor of 1/2. We get 1 over 54, I believe. Integrate 1 plus cosine double theta d theta. So 1 over 44 now, theta plus 1/2 sine double theta, which is 1 over 54 theta, plus 1 over 108 sine double theta plus RC. So we did integrate. And I know what you're thinking, because you might say, well, what about the limits? We're going to deal with these limits at the end. Okay. All right. Okay, so let's try to put this function in terms of the variable x. Before that, remember sine 2 theta is 2 sine theta cosine theta. So if I replace this, don't forget, that'll make my constant really 1 over 54 again, sine theta cosine theta plus c, because the numerator now would be a 2, and your denominator would be putting the 2 right up here. Anyway. Okay, looks pretty good. Now go back to the fact that we let x be 3 tangent theta. What that will mean is that our tangent theta is x over 3 when we solve for tangent. So we have our theta now. Definition is opposite over adjacent. So by the Pythagorean theorem, okay, we're going to get x squared plus 3 squared, which will be 9. So x squared plus 9. So, okay, let's go back and take a look. We need a theta. There's the theta. So theta will be arctangent inverse tangent x over 3. There's my theta. We need sine theta now. So sine theta, the definition of sine is opposite over hypotenuse. Sine is x over x squared plus 9. I think we need a cosine, right? We need cosine as well. Cosine theta is adjacent 3 over hypotenuse x squared plus 9. So altogether, I'm going to use blue. We get 1 over 54 times theta. Theta was the inverse tangent of x over 3 plus 1 over 54 times sine, which is x over x squared plus 9, times cosine, which will be 3 over x squared plus 9, plus c. So let's write this out this way. 1 over 54 inverse tangent x over 3 plus 1 over 54. But in fact, we can simplify. This will be 18. So we can write this a little bit more efficiently. X over 18, x squared plus 9 plus your constant c. Now, what you've found is the antiderivative function. This is big F of x. So if you had to integrate over these limits, what you can do is to consider it this way. This is big F antiderivative. Evaluate this now at x is 0, 2x is 1. So we can apply the limits at the very end. So 0 and 1, let me get rid of this. So we have some arithmetic to do. So we need to f of 1 minus f of 0. Okay. 1 over 54 inverse tangent 1/3 plus 1 over 18 1 squared plus 9 minus, I'll put this bracket, inverse tangent 0 over 3 minus 0 over 18 times, looks like 0 squared plus the 9. So this portion here is going to be 0, and inverse tangent 0 is 0. We got 0 here, so it looks like our only arithmetic to do is the first portion. And it looks like that's going to be 180, and there's no c anymore. So remember down here, 1 squared plus 9 is 10, and 10 times 18 is 180. So I'll write it. Final answers. I'd like to do this. Let's do this in black here. There you go. All right. So, this is how we handle an integral when you have the limits. Okay. 9. Looks like we have limits again for number 10. We'll apply them at the end as well, but I want to remind you about some algebra here. That you have a base to the 3/2 power. I think we've seen this a few times. So when you have a base to the 3/2 power, that's the base to the 1/2 raised to the 3rd power, which will be the square root of the base to the 3rd power now. Okay, so what's our base here? So this denominator, we have x over the square root x squared plus 1. Let me write it so we can see it. That's raised to the 3rd power down there with dx. Okay. So in this example now, again, if we focus on this 1, which will be a squared, so we've been saying, a squared is 1, which means a will be plus or minus the square root of 1. A is plus or minus 1, or a is positive 1. So, okay, now let's look what x should be. X is going to be a, if we remember, go all the way back, a tangent theta. think we went too far. Okay. X squared plus 1. Okay, so it's 10, 9, 8, 7. There we go. I'll erase it since this is a x squared plus a. So x will be a, which is 1, tangent theta. And then your radical is going to be a secant theta. A is 1 here. Okay, so we're using this information now because we have a radical of the form square root of x squared plus a squared. So let's bring that all down. Okay. So we have the x portion, we have the radical. Don't forget we need dx. So the derivative of tangent is secant squared d theta. Okay. So let's take a look at what this would be in our trig substitution. Just checking a few things here. All right. So the integral now becomes, we have already x in the numerator right here. Probably going to have to move this down, but that'll be x is tangent theta. We know that. The radical is secant theta, but that's being raised to the third power. And our dx is secant squared theta d theta. So maybe I can sneak that in here. Looks like we were able to. But let's make sure everything is what it should be. Dx will be what? Secant squared theta d theta. Okay. So I just want to remark that secant theta cubed is secant cubed theta. So using some algebra now, this term goes away. We got a secant theta in the denominator. So you have the integral now of tangent theta over secant theta d theta. So at this point, let's use some trig identities here, because we don't have a quotient of secant and tangent. We have a product, but we don't have a quotient. So tangent theta, remember the identity for tangent is sine over what? Cosine. The identity for secant is 1 over cosine. And I think we've been doing this in purple, so let's be consistent. Sine over cosine divided by 1 over cosine. Now, I want to remark, you can go through the complex fraction arithmetic, but I want to say that if we are both dividing by cosine, that's going to cancel. So you're going to see that this simply ends up with sine over 1 or we're really just looking at a sine function. So this gets replaced just with sine. All right. So that's nice. We're integrating sine. So this is minus cosine plus c. Going back to calculus 1, the derivative of cosine is minus sine, so it's going to be a minus cosine. All right, go back over here to the fact that x is now tangent theta. So we're going to use that x being tangent theta because we can also write that as a ratio that tangent theta is x divided by 1. We're going to create our right triangle because what we need to determine really is what is cosine theta. We know tangent theta is x. We don't know what cosine theta is. So opposite over adjacent, and then we get x squared plus 1 squared, which will be 1. Remember, there is no radical here. Well, let's see. Hold on. Let's remember, what is this? Triangle squared plus c squared equals x squared plus 1. Yeah, it would be the square root of x. Sorry. Square root of x squared plus 1. I apologize. There is a radical. All right, we need cosine though. So the definition of cosine of theta is the adjacent side over the hypotenuse. So there was a radical, like we said, it's right here. Always going to be a radical, I guess, if you have a radical to begin with. Okay. And definition of cosine right here. So we replace this now. Final answer is negative 1 over the square root of x squared plus 1 plus that constant c, because the integral is really a minus cosine theta. However, you had limits. So let's not forget the fact that we had some limits here. Right? Did we have limits? Yes. The limits go from 0 to 1. Zero to 1. So this is my antiderivative, but we had limits, so we have to evaluate this from x is 0 to x is 1, which really means we're going to have f of 1 minus f of 0 minus 1 over square root of 1 squared plus 1 minus a what? Minus 1 over square root of 0 squared plus 1. Negative 1 over the square root of 2 plus 1 over the square root of 1. Final answer will be 1 minus 1 over the square root of 2. So, ladies and gentlemen, there you go. All right, let's continue to do some more of these examples. This time we have integrals of this form, the square root of x squared minus a squared, and now we have x is a secant theta, and the radical will be a tangent theta. Remember, there was a typo we said, that's a minus sign. So x equals a secant theta, and the radical is a tangent theta. All right. Here we go. We notice we do have a radical, and this is my a squared value. A squared is 4. A will be plus or minus square root of 4, or A is plus or minus 2. A is positive, so this is going to be a positive 2. So x in this case, because it's of the form square root of x squared minus a squared, x is a secant theta, so it'll be 2 secant theta. The radical x squared minus 4 gets replaced with a, which is 2 tangent theta. But don't forget we need the dx. So dx will be 2, the derivative of secant is secant tangent. And that's our d theta. So let's get our colors out. This is x, the radical dx. All right. Okay, let's substitute. 1 over, not the radical, but 2 tangent theta. And then your dx is, let's see if we can fit this in, 2 secant tangent. I'm going to put it up here, 2 secant tangent d theta. So we'll get 2 times 1, which will be 2. 2's cancel, tangents cancel. This is the integral, ladies and gentlemen, of simply secant theta d theta. Let me see if I can write this nicer. All right. So remember that formula here for the integral is secant theta. Like I said before, you want to memorize that formula because it shows up a lot. That's the natural log, absolute value, secant plus tangent plus c. All right. Don't forget, x is 2 secant theta, because we're going to have to find out what some of these answers are. If x is 2 secant theta, solving for secant theta, that's really x over 2. So I can replace this here, this portion here, with x over 2. However, we got to know what tangent theta is. Well, if secant theta is x over 2, cosine is 2 over x, and cosine is adjacent over hypotenuse. Remember, the side will be the radical, so this will be x squared minus 4 here. Square root of x squared minus 4. Okay. So, since we need tangent, tangent is opposite over adjacent. There's my tangent function. So we replace that tangent really with square root of x squared minus 4 over 2. So your final answer is going to be natural log, absolute value, x over 2 plus square root of x squared minus 4 over 2, and absolute value plus c. So here's our final answer. Now, if you're looking back at the book, you might see that they get rid of that constant by using that algebra we talked about earlier here, right? So you can factor out the 1/2, x plus the square root of x squared minus 4 here. Don't forget, this is absolute value. Absolute value of a product is product of absolute values. But you're taking the natural log of this, and you're going to now use the product rule for natural logs. And then there's a plus c here, so if you're looking back at the book, don't forget, this is another constant. So a constant plus a constant is a constant. So very often you might see this answer, and then you might think that you did something wrong, but you really didn't. They just simplified by using a little algebra. So we talked about this earlier. So either answer would be okay on a test. I'm fine with that, but this is the gory detail. Okay, they're using some algebra and product rule for natural logs. All right. Okay, that brings us to the last one. So I think by now we know this is the integral of x squared over the square root of x squared minus 1 to the third power dx. We know a by now be positive 1. X is a secant theta. The radical is a tangent theta, and a is 1, so we don't have to put the 1 down. The derivative of secant is secant tangent. So you got the blue, you got the gold, we have the purple. So remember, this is the integral of the form square root of x squared minus a squared. So going back up here just to kind of remind you of this, this is what we're using. Okay. X squared is really secant squared. The radical is being raised to the third power, so that's just really tangent theta raised to the third power, and then your dx is going to be, I'll put it here, secant theta, tangent theta, d theta. So let me emphasize with our colors here. Secant to the third power theta, tangent theta over tangent cube theta, d theta. All right, let's just double check things, and then we notice that a tangent factor in the numerator goes away. This is tangent squared. So you now have the integral of secant cube theta over tangent squared theta d theta. We're going to have to do what we've been doing, is using properties, or I should say identities there for secant and tangent. So I'm going to get out the purple. Secant cubed is 1 over cosine cubed. So I guess we could just put the cosine cube here to the third power. See if I can do that. Yeah. I guess I'll just cube it this way. Tangent is sine over cosine, and don't forget that that's actually squared. So I get 1 over cosine theta to the third power now, divided by sine squared theta over cosine squared theta, which is 1 over cosine to the third power times cosine squared theta over sine squared. So we have 1 over cosine theta times 1 over, looks like sine squared theta. Okay. So it looks like we're now going to get what? Secant theta times cosecant squared theta d theta. Let's double check. All right. So we're going to have to use an identity here for cosecant squared theta. So I'm going to have to remind you, what is cosecant squared theta here? 241. So if we think of Pythagorean identities for cosecant squared theta, this is 1 plus cotangent squared. So you end up integrating secant theta 1 plus cotangent squared theta d theta, which is the integral of secant theta plus secant theta cotangent squared d theta. So we can look at this as secant theta d theta plus secant theta cotangent squared theta d theta. We already know this first integral, natural log absolute value secant theta plus tangent theta. But then the question is going to be now, what happens here with this integral? All right, let's find out what this integral is. So if I think of, again, secant theta, this is 1 over cosine theta. Cotangent is going to be cosine squared over sine squared. Okay? Where the cosines cancel. So you're integrating cosine theta over sine squared theta d theta. Now, ladies and gentlemen, this is u sub. I think we've seen this before, right? U is going to be sine theta, which means derivative of sine is cosine theta d theta. Or we know d theta will be du over cosine theta. So this integral will be cosine theta over u squared now, and d theta will be du over cosine theta. So you're going to get your cosine theta to cancel. You get 1 over u squared du, which is going to be u to the minus 2 du, which is negative 1 over u, plus e. But don't forget what u was, because this was u substitution, right? U was this sine squared down here. Well, u is sine, actually, not sine squared. And this is negative now 1 over sine theta. Or we should say this is negative 1 over, or not negative 1 over, that's negative cosecant squared theta. Don't forget plus that c. So, I think we colored that gray, and we've seen that before. So altogether, let's bring this stuff down, or let's recall at the very least. You have natural log secant plus tangent minus cosecant theta plus your constant c. So we integrated, and we got to go all the way back over here to remember that x is secant theta here, because we have to give our answer in terms of the function x. Copy, x is secant theta. So that's good, because that means this portion here is x So if we create our right triangle, we'll know secant theta is x over 1. If secant theta is x over 1, we know cosine theta is 1 over x. Cosine is adjacent over hypotenuse. So don't forget the radical will be the other side. And we could use algebra, but it's going to be easier to look at the radical. It's the square root of x squared minus 1. So square root of x squared minus 1. Now, you said, well, what do I need? We need both cosecant and tangent. So tangent is opposite over adjacent. So that's going to be simply just square root of x squared minus 1. So this is my tangent curve. Cosecant now. Let's think about cosecant. Well, we need to know what sine is. Sine is going to be opposite over hypotenuse. So cosecant is the reciprocal, x over square root of x squared minus 1. So, I mean, I think we were using some colors, maybe that's easier to see. Tangent, cosecant, x over the square root of x squared minus 1, but that means our final answer is going to be natural log absolute value of x plus square root of x squared minus 1 minus x over square root of x squared minus 1 plus c. Anyway, I think that concludes the demonstration. So ladies and gentlemen, I hope you guys appreciate this, and I will send it out to you, and take care. Have a great weekend.